So, last time we looked at how to read the tables to find a Poisson distribution, the probability of an event happening by looking at the charts. And so today what we're going to do is we're going to look at some applications. It is exactly the same process. It's just given to you in sentence form, so you just have to, so instead of on the chart, so you have to find the values. Remember that we need a lambda value, and remember that's the average amount. So for that accident one, it was 6 per year. So they average 6 every year, right? The period doesn't matter when you're finding the values. Your x value is the new amount that you need to find. And again, you're just going to read that straight from the table. And I have the table now on the screen, so I'll be able to show you exactly where those are. So we won't have to just have you follow along. Okay? Then you're just going to read the value from the table. But remember, use a probability statement and answer in a full sentence. Get used to that, guys. Anytime you're answering a math question here in NCEA, they want a full sentence. If you just give the number, you're likely, and it's the correct number, obviously, then you're likely to get an achieved. If you answer that number in context, in other words, using a full sentence in context, then that's what bumps it up to merit. Okay? So, just that simple act of writing it out as a sentence will make you the difference between achieved and merit. So, keep that in mind as we go. So what we're going to do is we're going to just go to the applications. We're going to do a few of them together, and then I'm going to set you loose because really you just need to practice making your mind work on the table. Okay? So let's just go to the book and look at a few of these. Okay? So last time we just read them from a chart. Right, we did these where you're just reading them from a chart and the different distributions. So this time we're going to look at some applications. Okay. All right, so we did a few where you just had to name the lambda and the x from a straight sentence, right? They didn't ask you to answer a question about them. So, all right, here we go. So on average, a delicatessen sells 1 jar of pickled snails every 2 weeks. Okay. Right? This is on page 40. So on average, a delicatessen sells 1 jar of pickled snails every 2 weeks. So first thing we need to determine is this indeed a Poisson distribution? It's 1 jar of something I can count in a defined period. And that's how you know that it's a Poisson distribution. Can you count jars? Yeah. So it's countable? It's got to be. All right? Do they give you a defined time? Yes? So that means it's a Poisson distribution. Right? And again, you can look for these keywords per or for every. You can usually use those keywords as well. So what is the theoretical probability that the delicatessen sells 3 jars of snails in a 2-week period? Now, let me warn you of something. And we may see it here in the homework. I haven't done these particular problems, but I was looking at the actual problems from the NCEA exams, and often they will give you 2 weeks here, and then they will come down here and say 4 weeks. What does that mean for all the numbers in the sentence above? You need to double them all, right? Or they may say 2-week period, and then they want to know in a 1-week period. So that means you need to divide it by 2, right? So be careful when you're reading these questions and watch those periods. It caught me yesterday. All right. So I need a lambda, and I never can draw those. I hope you draw them better. And that's just simple. That's simply the average that I have right now. And how many jars are they selling every 2 weeks? 1. And I need an x value, and the x value is how many is the new projected value, which is what? 3 jars, right? Okay, so I need a lambda and an x value, and that's all I need to be able to fill in my chart, go through the chart and get the information I need. Yeah? So when I push this button, it's all going to go away, but bear with me for a second. So let's go to our table. And here's the table. You have lambda across, x values up and down, and it goes through lots of different values. Remember that as the lambda gets higher, you have more options because these stop when it gets to 0. So that's why they don't always all go to the bottom, and why some have more than others. You see the chart gets bigger as you go. So we have a lambda of what in this case? 1. Yes, hopefully y'all are writing this down. Lambda of 1, and we want the probability of an x value of how many jars? 3. Right? So all you have to do is find the values you're given, the lambda across the top and 3 in the bottom. And you're just going to go across until those intersect. And they intersect right there at 0.0613. So, all right? No math involved, just reading the table, but read it correctly. Okay? So going back to our problem. Sorry, I'll get better at bouncing back and forth in a minute. The theoretical probability. So the probability that our x is exactly 3, right? So equals 3 is 613? Okay? Now, that's the number. That's good enough for an achieved. Probably all they're asking for in this case. But remember that if you always write it out in a sentence, you're likely to hit that merit stage. So you could write it out as the probability that a delicatessen sells 3 jars of pickled snails every 2 weeks is that number. Okay? The theoretical probability. They mention it here, so mention it there. So the theoretical probability that, right? And just write the sentence for the change. It's good? Let's look at a few more. And again, the only thing you really have to worry about in these is if they change the scales on you. Change the period, the time period. Okay, what is the theoretical probability that a delicatessen sells no more than 2 jars inclusive? What does that mean? We're going to include the 2, right? So no more than 2 of pickled snails in a 2-week period. So the period's the same, so I don't need to change anything, right? Always watch for that. And my lambda is still the same. It's still a 1. But this time we want to say no more than 2, right? So that means they can sell what? They can sell none,
They can sell
1, or 2, right? So we have 3 different values this time. Okay? So when we go to our chart, we're going to get 3 different decimals, 3 different probabilities, and then I need to combine them, just add them together. Because this is the same, remember for probability, or means add. This is the same as 0 jars, or 1 jar, or 2 jars. So you're just going to find the probabilities for each one and simply add them together. So let's go to our table. So most of the time you're just going to spend reading from the table. So again, our lambda is 1. That did not change. We want 0, 1, or 2. So that's these first 3 values. So what we'll do is simply take those first 3 values and add them together, and that's your job. Someone? Okay, so look at this one. So what's happened is they've changed the period for us. But all they want to do is find on average how many do they sell. So be careful what you're looking for. And this time I'm just looking for the x for the on average or our lambda, right? So we're not going to go to the charts for this. We're just going to look at the original question. Originally it was 2-week period. Now it's a 8-week period. So that's 4 times as many weeks, yeah? So we'll simply multiply all our numbers on the top by 4. Well, on average in 2 weeks, they were only selling what? 1. So in 8 weeks, we would expect them to sell 4. Right? Because 8. So all you need to do is take the 8, divide it by original 2, and that gives you your multiplier. And no, you don't have to put the working, but you would want to do more than, say more than 4 jars, right? You would want to say, on average, the delicatessen, yes, it's a pain. Just get used to it, okay? There won't be that many of these. You're going to be doing a lot of them in your homework, but there aren't that many of them on the test, okay? So now, if that's true, let's look at F. What is the theoretical probability that the delicatessen sells 10 jars in an 8-week period? So we want the probability that X is exactly 10. So I need a lambda, and my new lambda is how many jars? 4. And we want the probability that they're going to sell exactly 10. So now we're looking for a probability, so that means we need to go to the chart, right? So don't go to the chart unless you're actually asked for the probability. And we got to use our new numbers for that. So go to your table. And we now are at this table where lambda is 4. So we had to scroll down a bit. We're going to go down to 10. Going across, you're going to get right there. It's only one value because it's just one number. So 0.0053. So how likely is it then that they're going to sell 10 jars in an 8-week period? Not very. That's a tiny number, isn't it? Okay? So it's very unlikely that that's going to happen. Almost no chance at all. Okay? Who's going to buy a jar of pickled snails? Yeah, they're not going to sell any to me. All right. Okay? So again, all you have to do is when you know your lambda and you know your x, just read the values. By finding the intersection. What if I had wanted at most 10 jars inclusive? I wouldn't have just done... If I wanted at most 10 jars inclusive, that means all of these values added together. Now, but guys, focus. Come on. But there's a slightly quicker way to do it. If you remember some stuff about probability, instead of adding all of these together, I could add these that I'm not using and subtract that value from what? From 1. Right? So if the number you're looking for is more values than the number you're not looking for, you could always just add up the ones you don't want and subtract them from 1, and whatever is left over is what you want. Right? Exactly. So because remember, that's called the what? Complement? I think that's complement with an E. So complement of the value, right? Because remember that the probability of something happening and the probability of it not happening have to add to 1. So if you know 1, you can always find the other. Okay? All right, so you don't always have to add all these together if there's a long, long list. Add the shorter list together and simply subtract it from 1, if you want to. Okay? So you see what happens from there. 4 conditions for the Poisson distribution. List these and explain whether they or not these apply to this situation. What are the conditions for the Poisson? You've got them right in front of you in your book there. Turn back to the first page we looked at and read to me the conditions. That first page when we started talking about the distributions. Okay, so they have to be independent. Exactly. That means that one can't affect the other. Do you think that the number of weeks affects how many snails you sell? It doesn't really matter. Yeah, so it doesn't matter what week it is it? They must not occur simultaneously. Do we have simultaneous things here? No. They have to be random and unpredictable. Do you think that the sale of snails is unpredictable? I would think it is. Yeah. Okay? And for a small event, it's proportional to the size of the interval. So, was the interval small? Yeah. And we still got a small event. What if I did the math and I got like 50 jars in 8 weeks? Does that sound right? No. These are always going to be very small numbers that are in relation to the interval of time or space that you're using. Okay? Go back to these. This little question is the excellence part. Okay? So make sure you know. So make sure you know that describing these and developing the understanding is what's going to get you the excellence. Okay? You would just say, yes, because the events are independent. They cannot occur simultaneously. They are very random or unpredictable, and they are proportional to the size of the interval. Yeah. Okay? All right. So what I'm going to do is I'm just going to get you an assignment. So what I want you to look at is just continuing. So what is that? 39, page 40 we were on? Okay. So 40 and 41. Here's somewhere you're reading the information from a graph. Okay. Remember when you're reading from a graph, so what's the probability of a 2 on this particular graph? So about 2.7, 2.8, somewhere like that, right? Just read how high it is, that'll give you the probability. So sometimes your probabilities are going to be given in another area, okay? But we want the average. So you're going to have to go back to that calculator business we did last time to get the average, right? Because all I'm given is a bunch of values here. I need to find the average of those, right? And that's that X value when you put them all in the list 1 and list 2. So this will give us some of that calculator practice that we desperately need as well. Okay? So the very first day we were here doing these. All right, so it's a little bit combined. So, page... Oh, wow, there's a lot of these. But little bits and pieces. So up to page 43. Now, at least do some of them. If you don't get them all done, and work with the rest of the class, but try to do some from home. Yeah, start at page 40 and do some of them. Look for things. Look, if they're very straightforward ones, skip it and move on and do something that doesn't look so straightforward, right? But get some experience with these. Okay, there we go.